Welcome back everyone. In today's session we will be solving the next questions of exercise 6.2. In the last session I explained you question number 2 and question number 1 of exercise 6.2. These are important for 1 mark. These are 1 mark questions. Now in today's session we will be solving question number 3, 4 and 5, okay, by using BPT. Okay, this whole exercise is based on BPT and its converse. So these are very simple questions which we are going to solve today, and they are important too. So let's see how to solve question number 3 first. So in question number 3 it's given that DE is parallel to AC and DF is parallel to AE. You can see the figure is given to you. DE is parallel to AC in the figure, and AE is DF is parallel to AE. So I can use BPT twice here. Okay, what the BPT theorem says? BPT says that if a line is drawn parallel to one side of a triangle, it divides the other two sides in the same ratio. Okay, divides the other two sides in the same ratio. So that concept I am going to use here for proving this theorem. So we have to prove that BF by FE is equals to BE by EC. Okay, very simple. Let's proceed with the theorem. So given, I have written given, and to RTP, that is BF by FE is equals to BE by EC. Now in triangle ABC, in this triangle ABC, DE is parallel to BC. It's given to us. You can see in triangle ABC, DE is parallel to BC. This is given to us. So if I use BPT here, I'll write this statement once, no need to write it twice. Okay, you should write the statement of BPT once. So if I apply BPT here, I can say that, you can see this DE is parallel to AC. Okay, so I can say BE by EC is equals to BD by DA, isn't it? Because DE is parallel to AC, BE by EC is equals to BD by DA. This is our equation number 1. Then again I'll take triangle AEB now. In triangle AEB, DF is parallel to A. You know which line is parallel in this triangle? You can see DF is parallel to AE. So when DF is parallel to AE, I can say by BPT, BF by FE is equal to BD by DA. Okay, very simple. We are applying BPT twice, so we are getting 2 steps here. Now from equation 1 and 2, you can see this is equals BE by EC is equals to BD by DA, and BF by FE is also equals to BD by DA. Now you can easily understand which property I am going to use, that is Euclid's axiom. Things equal to the same thing are equal to one another. So from equation 1 and 2 I get BF by BE by EC is equals to BF by FE. Okay, we'll remove the common part. Okay, I always give you the example. If A is brother of B and C is also brother of B, then who are A and C? A and C are also brothers. Okay, we learned this concept in 9th class. So from 1 and 2 we get BF by F is equals to BE by C. Hence we got our RTP. We proved it. This is the way we are going to solve question number 5 also. In question number 5 you can see DE is parallel to EQ. In this figure you can see this line DE is parallel to EQ. OQ, sorry. DE is parallel to OQ and DF is parallel to OR. DF is parallel to OR. So here also I can use BPT twice. Once I can use in the green color triangle, okay, and next I can use in the blue colored triangle. So I have written what is RTP here. We have to show that EF is also parallel to QR. EF is parallel to QR. Okay, the figure will be given to you. Again, see the question. DE is parallel to OQ, DF is parallel to OR. So we have to prove EF is parallel to QR. This is our RTP. So I have taken given and RTP here. Now I'll use BPT for BPT here in triangle PQO. First I'll take the green colored triangle. In green colored triangle, EO is parallel, DE is parallel to OQ. Okay, DE is parallel to OQ. So when DE is parallel to OQ, I can say PE by EQ, isn't it? PE by EQ is equal to PD by DO. That is our equation 1. Now let's apply BPT for the blue color triangle. Here DF is parallel to OR, so I can say PF by FR is equal to PD by DO. You can see the second condition, that is PF by FR is equal to PD by DO. So applying by using BPT, we got two conditions, two cases, and in these two cases you can see they are equal to the same thing. P by EQ is equals to PD by DO. This is also equals to the same. So again, using the same rule, Euclid's axiom, from 1 and 2 we get PF by FR is equals to PE by EQ. So these two will be equal because PD by DO is common in both. So PF by FR is equals to PE by EQ. Now PF by FR, you can see this PF by FR is equals to PE by EQ we have got here. So what can I say now? By converse of BPT. Okay, what converse of BPT says? If the sides of a triangle, if any two sides of a triangle are divided in the same ratio, okay, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to third side. So which line is dividing this triangle, this sides into equal ratio? EF. So I can say by converse of BPT, I can say EF is parallel to QR. So we are using BPT as well as converse of BPT. Okay, and if this is asked for 4 marks, it is advisable for you to write the statement of theorem, or else if it is asked for 3 marks, we can write just by BPT also, by converse of BPT. So it's better if you write the statement of the theorem. Okay, so these are simple problems based on BPT. Now let's see the next question. In figure, A, B and C are points on OP, OQ and OR respectively. So you can see here A, B, C. You can see A, B and C. These are the points on OP. Where is A? It is on OP, B is on OQ and C is on OR respectively, such that AB is parallel to PQ, AC is parallel to PR. Okay, AB is parallel to PQ and AC is parallel to PR. You can clearly see that in the figure. So this is given to us and we have to show that BC is parallel to QR. Okay, we have to prove BC is parallel to QR. So let's see how to solve this theorem. Again, we'll apply BPT here. I have taken what's given and what's RTP. Now I'll use BPT step by step. First I'll use BPT for the triangle OPQ, that is the green colored triangle. Okay, OPQ. So if I use BPT here, I know that in this triangle OPQ, AB is parallel to PQ. So I can say that OA by OP, okay, OA by AP is equals to OB by BQ. Okay, if a line divides, if a line cuts two sides of a triangle, if a line is drawn parallel to one side of a triangle, okay, then it divides the other two sides in the same ratio. That statement you can write here, or you can write by BPT also. So by BPT we have got OA by AP is equals to OB by BQ. Then again I'll use BPT for the blue colored one. Here what do I get? Here I get OC by CR is equals to OA by AP. Okay, because this line is parallel to PR. Now in equation 1 and 2, again OA by AP is common. You can check. This is equals to OA by AP and this is also equals to OA by AP. So from equation 1 and 2, what do I get here? I get OC by CR is equals to OB by BQ. This is the result of equation 1 and 2. So we have got OC by CR. You can see the green colored part. OC by CR is equals to OB by BQ. Okay, the sides of a triangle are divided in the same ratio. So the line which divides them in the same ratio is BC here. Okay, so this line will be parallel to the third side. So as the sides are divided in the same ratio, OC by CR is equals to OB by BQ, then I can say line BC divides the triangle in the same ratio. So BC is parallel to QR here. Okay, so BC is parallel to QR. Very simple. In all the three equations, I applied same theorem, and even the steps are also same. Very simple. Complete it and even practice it. Right.